Okay, now let's move to past paper questions about this topic. We have stated before that one of the most important application of integration is to find the area between the curve and the x-axis. But for this kind of problems, please pay attention, because for that problem we have two areas bounded between the curve and the x-axis. One area is above the curve and below the x-axis, and we should expect that this area should have negative value. Otherwise this area part should have a positive value, because it's above the x-axis and below the curve. So this kind of problems may represent some confusion for student, and sometimes they get fatal mistake in this problem, because we have two values, one positive and one negative. So please execute the steps step by step, like what I will do. First, for A, he wanted to write down the x coordinate of A and B. So we can get this point by finding the roots. The question gave me the equation of this curve factorized, so it will be very easy, and we know how to find the roots just by solving the equation x times x plus 3 times the 2 minus x equal 0, and the roots, so the roots will be x equal 0, or x equal negative 3, or x equal 2. For x equal 0, this is the origin point, and the question have given this point to me, and now we want to find A and B. It's clear that A is the negative solution. This is A, so A x coordinate will be, this A will be negative 3 and 0, and the x coordinate will be negative 3. For point B, the point B is in the positive region, so B will be 2 and 0. Now for part B, we want to use the integration to find the total shaded area. So we have the equation of this curve y equal, as I have remembered, x times x plus 3 times 2 negative x. As we know that the area is integral from a to b y dx, so we want to integrate from a to b this expression by expanding these brackets. It will be x times 6 minus x negative x squared, and it will be 6x negative x squared negative x cubed. So now we wanted to make integration from a to b for 6x negative x squared negative x cubed dx. This integration will be, as we have learned before, from a to b, x squared 6x squared over 2 minus x power 3 over 3 minus x power 4 over 4. Now I prefer in this kind of problems to calculate the two parts of area separately. So I will name this area by A1 and this area by A2. Area A, A1, it will be equal the integral of y to the x from negative 3 to 0. Negative 3 to 0. It will be 6x squared over 2 x cubed over 3 minus x power 4 over 4 from negative 0 to 0. Substituting now x by negative 3 by 0, and then by negative 3. This is 0, 0, 0. Now here negative 3, negative 3, negative 3. If you calculate this by your calculator, for A1 to be negative 63 over 4. So I have said before that this area will have a negative value, which is negative 63 over 4. And for area 2, we will use same method to find the area of area 2. For area 2, same method, it will be the value of the integral from 0 to 2, 6 x squared over 2 minus x cubed over 3 minus x power 4 over 4, and you calculate the difference between the value of this function at 2 and at 0. 6 to power 2 over 2 negative 2 power 3 over 3 negative 2 power 4 over 4. And for this term it will be 0, but it's okay, over 2 minus 0 power 3 over 3 minus 0 power 4 over 4. It's very easy, just to substitute x one time by 2 and again by 0. As we know, this term will be 0, and the answer will be by using calculator 16 over 3. So A2 is 16 over 3, and we have expected that this value will be positive because it's above the x axis. It will be 16 over 3. Now the most important remark up there is to concentrate that this area is negative and this area is positive. So if you add these two area, you actually subtract these two areas, not adding. We wanted to add the value or the absolute value of the two areas. So the answer will be total area, either to state that the total area is E2 minus E1 and substitute E2 by 16 over 3 negative or minus negative 63 over 4 for A1, and the answer will be 16 over 3 plus 63 over 4, and to get the total answer by using your calculator, 16 divided by 3 plus 63 over 4. The answer will be, using a mixed number, it will be 21 and 1 over 12. To avoid the confusion, you can consider this total area as the sum of the absolute value of A2 and A1. So you will write 16 over 3 plus the absolute value of A1, which is 63 over 4, to have the right answer 21 and 1 over 12. This is area unit. Okay, now we'll move to another application of the integration, and we have said before that we can use the definite integration to find the area bounded between a curve and a straight line. And also, for your information, you can use integration as well to find the area between two curves, the area bounded between two curves. But this point is beyond the scope of your study in C12. You can study it in C34.